Hi guys, welcome to this page of the notes. Again, what we're doing is we're working on that second objective where we are simplifying complex rational expressions, and hopefully what you're doing is, because these aren't that terribly difficult, you're coming back and checking your answers with me here. All we need to do, since I have multiplication of these rational expressions, is I would start by cross-canceling first, then multiply the numerators and the denominators. That way, once I do my multiplication, I know I will already have my expression in simplest form. There won't be a GCF left in the numerator and the denominator to pull out. So let's go ahead and do this, and let's see what we can get rid of by cross-canceling. So my numerator, 8t squared and s, 12t cubed and s squared. Well, the 8 and the 12 will both reduce. I can pull a 4 out of both of those. That's going to leave me with a 2 and a 3. 2 of the t's in the top will cancel with 2 of the t's in the bottom, leaving me with just 1 t left over. The s in the top will cancel with 1 of the s's in the bottom, leaving me with just an s. I apologize, that looks a little funky. That is a 3. Okay, let's go the other way. Well, 5 and 15, man, we see that 5 and 15 a lot. That's going to reduce to a 1 and a 3. I have an s in the top, but I don't have an s down here, so they can't cancel that s. But I do have an r in the top and 2 r's down here, so that r in the top will cancel with 1 of my r's in the bottom, and there we go. Let's rewrite this guy. So now what's left is I just have a 2 left up there in the top, that's all. In the bottom, I have a 1 and an r. Well, that's just an r. Multiplied by, let's see what's left over up here. I have a 3 and an s, so that'd be 3s. In the bottom, 3, t, and an s. So 3, t, and s. Ooh, before we keep going though, check this out, guys. Notice I have an s in the top and an s in the bottom. So the reason I gave you this example problem is even after you get done cross-canceling, look to cancel top and bottom as well. Please notice that that s in the top will cancel with that s in the bottom, leaving me with 2 over r times 3 over 3t. Check that out. That's not the only thing. I have a 3 in the top and a 3 in the bottom. Get rid of those as well, leaving me with 2 over r times 1 over t. Now I have canceled everything. I've canceled all of my GCFs, all of my greatest common factors, and what I wind up with is 2 times 1, which is 2, and r times t, which is rt. So 2rt, where? Again, because they're multiplied, there's only one set of conditions where I would wind up with a 0. That is if r is 0, so r can't be 0, and t cannot be 0. And again, that's because those variables are multiplied in the bottom. If I had r minus t or r plus t, right, then there'd be an infinite number of possibilities, right? If r was a plus 3 and t was a minus 3, they'd go away. Or if r was a plus 5 and t was a minus 5, they'd go away, right? If there were a plus or minus sign down here, there's an infinite number of possibilities. Because they're multiplied, there's only one set of conditions on where those guys will wind up being 0. Okay, let's keep going here on the next one. This one is a division problem. I recognize I have that division sign in there. And so now what I'm going to need to do is multiply by the reciprocal. So let's do that first. Okay, so again, whenever you are dividing rational expressions, right, we will simply multiply by the reciprocal. It's keep it, change it, flip it from middle school. Keep the first rational expression, change the division to multiplication, flip the second guy. Take the reciprocal of the second guy. And then let's look to cross cancel if I can. 14 and 21, well, a 7. A 7 will come out of both of those, leaving me with a 2 and a 3. P in the top will cancel with a P in the bottom, leaving me with a P squared. Q in the bottom will cancel with a Q in the top, leaving me with just a Q. The other way, 15 and 35 should be 5, so that's going to leave me with a 3 there and a, 7 there. I 3 of the W's in the top will cancel with 3 of my 7 W's in the bottom, leaving me with 4 W's left over. 3 of the Z's in the bottom will cancel with 3 of the Z's in the top, leaving me with 5 Z's up here. All right, now let's go ahead, rewrite this guy because I've got little extra things running around all over the place. So I'm left with a 2 and a Q all over. I'm left with a 3 and a W to the 4th. Well, I don't have anything in common there. 2 and 3 won't reduce. Q and W won't reduce. Multiplied by, I have a 7 and a Z to the 5th. And in the bottom, I have a 3 and a P squared. And I take a look at this, 7 and 3 won't reduce. Z and P, they don't have anything in common, and so there's nothing else to cancel here, so we multiply these guys together. 2Q times 7Z to the 5th, well, 2 times 7 is 14. Q, Z to the 5th, all over 3 times 3, well, that's going to be 9. W to the 4th, P squared, and again, those variables in the bottom are multiplied together. So the only way I would wind up with 0 in the denominator is if W were equal to 0, so we'll restrict that, W can't be 0, and if P were equal to 0. So we will restrict that, P cannot be equal to 0, and you have simplified that rational expression and restricted the domain. Guys, head on over to the next page of the notes. We'll try a few more of these. I'll meet you guys there.